In this lesson, we are going to be working on solving exponential and logarithmic equations. In the last lesson of 3.1, we worked on rewriting into a logarithmic form. Basically, we worked on exchanging from an exponential into a log or a log into an exponential. Remember, the values of that is simply a formality. We can easily use another variable in the place of those. Remember, the base of the exponential becomes the base of the log, and the outside and the inside will switch places. Also, we talked about how we can use the change of base formula. But remember, we can simply also just use our calculator, looking for the log base button under the math key. Let's go ahead and start with some exponential equations. We want to go ahead and solve these just as we might solve if we didn't have a power. For example, on this first one, we'll go ahead and add 3 to both sides, and that'll get me to 4x equals 15. The next step, once the exponential function is isolated on the side by itself, now we can turn this from an exponential into a log. So remember the format. We have the base b of the power of m equals n. Converting that into a log base b, the inside and the outside switch places. So in this case, we would have log base 4. The base is going to drop down. The outside and the inside switch places. Here we can go ahead and just use our calculator, and the value of log base 4 of 15 is 1.95. And rounding to the second decimal place is perfectly fine on these. On this next problem, it's very similar to the last one, just a few additional operations. Here, when we subtract 5, we have negative 3, 2 to the power of 3x minus 8. We get negative 48 on this side. We are not going to distribute into the parentheses. What we want to do next is we want to divide to move that number over to the other side. So we'll be left with 2 to the power of 3x minus 8 equals 16. We are not dividing here. A lot of students will want to divide by 2. What we have is we have an exponential form that we need to now turn into a log. So we will have log base 2, the outside and the inside will switch places. When we calculate log base 2 of 16, we're going to get 4 equals 3x minus 8. And we can now solve this just as a two-step equation. And we get x equals 4. So for this next example, it's going to be a slightly different process. What we're going to do is we're going to apply the log property. If you remember the log property, when the log has a power, then that power swings to the front of the log. So in this particular case, what we're going to start to do is we're going to take the log of both the left side and the right side of this equation. What's going to happen next is this power is going to swing to the front of that log, and the same on this side here. Now, if you remember what we discussed the other day, that a logarithm is just a decimal answer. If I were to take my calculator and I were to type in log 9 on my calculator, I would get approximately 0.954. And over on this side, I would get approximately 0.699. And so now what I've done here is I've just simply created a multi-step equation where I can take that decimal and distribute it into the parentheses, and I'll get 0.699x plus 2.097, and I'll distribute on this side 0.954 times 2, and I will get 1.908x minus 0.954. And again, now I just have a multi-step equation that I can finish solving. So I'll move my x's over to one side and my numbers over to the other. And I will add 0.954. And that will give me 3.051. And then I'll subtract 0.699x. And then I can divide and solve for x. So I would have 3.051 divided by 1.209. And I will get x equals 2.524. Now again, on that one I rounded out a little farther. I'm fine with 1 or 2 decimals as long as the process is shown there. Okay, so those wrap up solving exponential type equations. So here in these, we are taking an exponential and turning it into a logarithmic function. Let's move down and let's go the opposite route. So essentially here, we're first going to try to isolate the logarithm. And then we're going to do the conversion. Remember, on that conversion, we're now going to be left with a log, converting it into an exponential function, and solving where appropriate. All right, so here, again, I would try to isolate the log. So the log currently right now is by itself. So since it's already isolated, I now have a log that I need to turn into an exponential. So again, the base of the log becomes the base of the exponential. The outside comes in and the inside goes out. I will use a calculator to calculate 4 to the third, which is 64 equals x over 2 plus 3. And then I will just finish up solving like a simple algebraic equation. So I'll subtract 3 and I'll multiply by 2. And here I will get x equals 122. Now remember, you could always take that x back in and you could always plug that back into your calculator if you wanted to check your work to see that that equals 3. You don't have to do that, but it could be helpful for you to work those out. All right, let's take a look at this next equation. Again, isolate first. This is isolated all by itself. So now I'm going to take a log and turn it into an exponential function. Now remember, this log doesn't have one shown, so I'm going to write it with a base of 10. Remember, if it's missing the base, that means it's 10. Remember, when we have a log, to get it to go into an exponential, the base drops down, the inside and the outside switch places. So now I have 10 equals x squared minus 3x. Well, here what we have is we have a quadratic. In order to solve a quadratic, the easiest method is to factor. If we need to factor it, it must be set equal to 0. So here I will move that over. Factors of 10, that will give me -3. And my solutions to this problem would be 5 and -2. All right, on this last example that we have a combination here of two logs. So it's very important that we use log properties first. Okay, and here I can see that it is like the property of log of m minus log of n, or I think in our notes from yesterday we use x and y. And remember, if it has subtraction, when we bring it together, it creates a division problem. So if I write this as log of x minus 3 divided by log of x plus 1, I can group that log together, and now I can solve it. Remember, this has a base of 10, so I'll add that in. I'll now convert it. The base of 10 to the power of 2. Inside comes in, or outside comes in, and the inside goes out. And now I will solve this problem. 10 squared is 100. In a situation like this, I'm going to have to take this whole denominator and multiply it all the way across. And I'm going to subtract that x, make 99x. I'm going to move that 100 over. And now I can solve for x. X equals negative 1.04. All right, so that finishes up the lesson of solving a log equation using conversions from a log to an exponential. All right, moving on to the next section, we are going to be looking at equations that use natural logarithms. In natural logs, we're going to be using e's and ln's. What we need to know is that these are inverses of each other, and e and ln cancel each other out. In fact, if you took a calculator and typed ln into your calculator, which is on the left-hand side of your calculator button, you'll see the word ln. Okay? If you typed in ln of e and e raised to the power of 5, you would get 5. Those would cancel each other out. If you reversed that and you said e to the power of ln of 2, you would get 2. Again, those two cancel each other out and allow you to solve that. Why don't you go ahead and locate the E and the ln button on your calculator? All right, now that we've located those buttons, the first step again is to isolate. If we have multiple ln's, we might need to use log properties. We're going to use E and ln to cancel each other out, and then we're going to solve for x. All right, in this first example here, we are starting with an E. Again, so the first thing we want to do is isolate the exponential function. So I'm going to add 4. I'm going to divide by 1.25. I'm going to use my calculator to get that division. And when I divide that, I'm going to get e to the power of x minus 2 equals 9.6. You can see now that I've isolated this e. So now I'm going to use ln to cancel that out. So if I use ln on this side, then I have to use ln on the other side. When I use e and ln together on the same side, they cancel each other out. And this is just a calculation on your calculator. When I type in ln of 9.6, I get 2.26. And then I can add 2 to give me 4.26. Let's try that with one problem that's a little step up from that. So again, we're going to isolate that exponential. So we're going to try to get this exponential on the side by itself. It's going to take a little work to get there. The first thing I'm going to do here is subtract that 1. Now, what I like to do is I need to get this whole group out of the denominator. So I'm going to do a little switcheroo here. I'm going to take all of this and move it to the outside. So I'm going to have 200 equals 3 times 3 plus e to the power of 4x. Now, you have a couple of options here. You could distribute. I'm going to go ahead and divide. 200 divided by 3, and that gets me back to where this is on the side by itself. Of course, that is a decimal, which is perfectly fine. You can go ahead. We've been working with decimals here, so I'm going to go ahead and write that as a decimal. And I'm going to go ahead next, and I'm going to subtract this 3, and that's going to give me 63.67. And you can now see that I have this e, or the exponential, isolated by itself. So now it's time to go ahead and use the ln to cancel that out. So I'm going to use ln, again, if we use it to the left side and the right side here as well. So I would have ln of e to the power of 4x. Again, when we use that e and that ln next to each other, they're going to cancel each other out. I'm going to go ahead and use a calculator here, and I'm going to type in ln of 63.67. That's going to give me 4.15. The e and the ln cancel out, and then I can divide, and I'll get 1.038. Now, depending on how you round, it might round the decimal a little bit differently, but you can see we've kind of followed the same steps here. We've isolated the exponential, so always be thinking of what is that exponential that you want to get on the side by itself. Once we've isolated, then we use the ln in order to solve it, cancels that out, and solve the equation that's remaining. So we have this problem here. This is going to come about in your notes, and it's slightly different. And I'd like you to think about this as if you have the quadratic equation. So we're essentially going to use these values here. Okay, we're going to kind of turn this into x squared minus 4x plus 3. So if you were to think about this being factored, you would say x minus 3 and x minus 1. Except we don't have x's, we have e's. So if I were to convert this back over, I would have e to the power of x minus 3, and I would have e to the power of x minus 1. So if you think about how you might factor a quadratic, you would do the same thing with this. Again, that equals 0. And now essentially I have two mini equations that I can solve. E to the power of x minus 3, and over here e to the power of x minus 1. And then I can solve this, e to the power of x, and I'll use ln to solve both. This is going to cancel, and this is just simply a calculator operation. And the same thing on this one over here. So I'll use ln to both sides. Cancels this out. And I have a simple calculator operation. And I get two solutions on this one. So it starts by looking a little bit different than the others, but it's actually very easy to solve. All right, so in this example where we're going to start working with ln's, we're going to do the same idea where we had to isolate that ln. So we want to figure out what the ln is on this side, and we want to get that on the side by itself. So our first move here is going to be dividing by 40. And 25 divided by 40 is going to give me 0.625. Again, we're not worried about decimals. We've gotten decimals on almost all of those answers, so we're fine working here. And we're left with ln of x plus 2. You can see now we've isolated this, so now instead of using ln, we're now going to use e. But e is a base number, so when we use e in our calculator, it's actually going to raise that number up to a power. And the same thing will happen here. When we use our calculator to type in e of 0.625, we're going to get about 1.868. Here we know when we use e and ln next to each other that we're going to cancel those out. And then our last operation can just be to subtract 2. And when we subtract 2, we're going to get approximately 0.132. So this is just a very basic problem where we are using ln's. In the next two, we're going to see some different types of equations. Here where we have ln's on both sides, and also where we might need to use log properties. And the things about ln's and e's is we can actually use the same property here that we did for the logs. And so if you remember, again, if we have two logs that are subtracting with each other, then that is going to turn into division of those logs. Now we've had two examples like this. This could easily be something where they're maybe multiplied together. Here I have ln of x minus plus 3. And then I'm going to be subtracting, so that's going to turn into division. And then it's equaling ln of 1 over x. Now, here's the thing about this. If I have two things, one on each side, I have an ln on the left and an ln on the right, what's going to happen is those ln's are actually just going to cancel out. It's the same thing if I had log of 3 equals log of x. The logs would just cancel and I would have 3 equals x. So the same thing happens here. Those ln's are going to cancel and I have x plus 3 over 4x plus 2 equals 1 over x. And now I can cross multiply. I can distribute. And again here, I have a quadratic. So I will practice solving quadratics by getting it all set equal to 0. I will factor it. And now I can say x will equal 2 and x will equal negative 1. The next one's very similar. If you want to go ahead and give that one a try, you're welcome to. I'll go ahead and work through that. You're welcome to pause and stop and move on if you're ready. If you feel like you need to watch this last video example, you certainly can. Here I have ln of x minus 3. I'm going to use the properties on this side. There's an ln on both sides, so that ln on both sides is going to cancel. I'll take this denominator and I'll move it over to the other side, which means I'm going to have to do a little multiplication. Doing a little bit of multiplication here, foiling would give me minus 2x minus 3. Again, I have a nice quadratic that I can work with. If I subtract 7, it will give me 9. If I add 23, it will give me 20. I can factor it. and I can solve. All right, so that wraps up the lesson of solving logarithmic equations using exponential functions, using logs, using ln's, and using e's.